Welcome back for more physiology. I want to tell you a little bit about bones, and this is only so that we have kind of an idea as to what we're dealing with when we deal with the skeleton. It's not because I really want to test you on this, but it's nice to have some type of background about bones. First and foremost, they're alive. They're composed of cells that we call osteocytes, and what those osteocytes do is they create a whole bunch of fibers, collagen fibers, and they secrete chemicals that allow for a somewhat rigid or minerally gel substance that we would call bone. What those osteocytes are capable of doing is changing the bone throughout your lifetime. So the result is about every 7 years, you get a brand new skeleton because we're going to get rid of the old parts and put in brand new parts. It might look the same, so you might not detect it, but chemically, you have a fresh skeleton every 7 years. And when I look at these bones, components of your skeleton, they turn out to have many functions. So in part, they help keep parts where they are. They're going to be protective. They're used for us to move because we attach skeletal muscles to them. It's where we store a lot of substances, namely minerals. It's also where we store fat. But they also turn out to be where we make blood. So bones are actually far more dynamic than we usually give them credit. They come in two varieties. They have what we call trabecular bone or spongy bone, which is found on the tips, so at the top and the bottom of this picture, what we would call the epiphyses. And then in the middle, you have what we would call compact bone or solid bone. And they all turn out to have different functions. The way that we turn out to make bone is actually somewhat fun. And that is if I look at the ends of what we would call long bones, there's a layer of cartilage there that will actually expand, and when it expands, it then turns into bone, then expands again, turns into bone, expands again, turns into bone. We call that a growth plate, and it's actually how we make your bones get longer and longer and longer and longer. Because bones can turn cartilage into bone or into solid bone, and they have blood vessels in them, that means if I were to break a bone, I run the risk of making it bleed. Whenever something bleeds, it's going to form a massive clot. What we can do is we turn that clot into a scar. That scar is going to be made out of collagen, which in the presence of bone, your body says, oh, okay, and it turns it into bone. The result is I can look at a skeleton, and if there is ever a broken bone in it, you can see where the break was because it's as obvious as day. Bone remodels itself, which I already pointed out to you, and it turns out it's controlled by some cells called osteoblasts and osteoclasts, which means cell makers and cell breakers. But it's also controlled in part through some hormones called calcitonin and parathyroid hormone, which are things that you've never heard of before because for the most part we don't have issues with those. But what those two hormones deal with is, do we have more calcium in our body floating around in the fluid, or do we decrease the amount of calcium floating around inside of our body? And turns out both of those cause feedback loops, negative feedback, in order to make sure that we have the right amount of calcium floating around. If I look at bones, there's a whole bunch of different shapes of them, and we try and remain consistent. So if a bone is long, we call it a long bone. If it's short, we call it a short bone. If it's flat, we call it a flat bone. If it's not one of those, we call it irregular. We also have bones hidden inside of little cracks called sutural bones or Wormian bones. We don't care about them. They don't have any names. Because when we put the entire skeleton, we put it into either the dead center, which we call the axial skeleton, or it's the parts that hang off the sides. We call those appendicular. But not all bones turn out to fall under those two categories. If we were to add them all up, because we have nothing better to do, we have about 206 bones that we give a name to, but you have more than 206 bones because we have bones hidden inside of different cracks.